Hello students, welcome to my new class. In today's class, I am going to explain how to find out chiral carbon or chiral center. Before explaining different examples, I am going to define what do you mean by chiral carbon or chiral center. I am going to explain these topics in a very simple way. Suppose you have one carbon atom here, and if this carbon atom is going to attach with four different group A, B, C, D, then this carbon is called chiral carbon or chiral center. Both are same. So from this explanation at the very beginning, we have an idea about what is chiral carbon. Now let me explain by taking different example. Okay, let's see. We are taking in today's class the first example of this compound. Suppose you have this one. This carbon is attached with another carbon chain. This carbon is attached with one CH3 group. This carbon is attached with one OH group. This carbon is attached with one fluorine atom. Now for this compound, we will find out how many chiral centers are there. So to find out how many chiral centers are there, first we will assign the carbon which has four different atoms or group of atoms. If I am talking about this center is attached with another hydrogen atom. This center is attached with 1 and 2 hydrogen atom. This center is attached with another hydrogen atom. This center is attached with 3 hydrogen atom. And if I am talking about all these carbon, 2 hydrogen atom is there, 2 hydrogen atom is there, 2 hydrogen atom is there, 2 hydrogen atom is there. And this carbon is attached with this CH2 fragment, and this carbon is attached with this CH2 fragment. So first we will assign the carbon having four different groups. So if I am talking about this one, I am making one circle, this one. So this one is chiral center, CC. CC stands for chiral center. So this carbon is attached with four different. One is fluorine, the second one is hydrogen, third one is this methyl fragment, and the fourth one is CH2. So this carbon is chiral center. And if I am talking about another one, this carbon is also chiral center. You can say CC. Why? This CH3 is attached with this CH2 fragment, another H, another CH3 group, and this different carbon center. So you can see this center, this carbon is chiral and this carbon is chiral. Okay, one more thing is there. What about this carbon? This carbon is not chiral. I am giving one cross here. If this carbon is not chiral, this carbon is attached with CH2 and CH2. That means out of the four groups, two groups are same. So we can't consider this carbon as a chiral center. But if I am talking about remaining part, this one is not a chiral center. This carbon is not a chiral center due to the same hydrogen 2 hydrogen atom, and this part also is not a chiral center. So from this molecule we can say we have total chiral center is 2. It is a very simple example. Now let me talk about another example. I am going to draw a different molecule. If you want to take a screenshot, you can take it. Okay, Now let's go to another problem. Okay, now I am talking about a compound whose structure is like that. A six-membered cyclic six-membered ring attached with this bromine, and in the same way this carbon is also attached with another bromine atom. So now we have to find out how many chiral centers are there for this particular molecule. If you observe, this is attached with 2 hydrogen, this carbon is attached with 2 hydrogen, this carbon is attached with 2 hydrogen, and this carbon is also attached with 2 hydrogen. If you observe, this carbon can never be chiral, this carbon can never be chiral, this carbon can never be chiral, this carbon can never be chiral due to the presence of the 2 same hydrogen atoms. So now we will check whether this 2 carbon is chiral or not. But one thing you should keep in mind, if you consider this carbon, so this carbon is attached with 1 bromine atom and this carbon is attached with in the right hand side and in the left hand side, both the groups are same. And one more thing is there, it is attached with another hydrogen atom. Okay, so bromine and hydrogen is different, but the left side unit and the right side unit for this carbon is same. So the top carbon is not a chiral center, and in the same way the carbon present in the opposite direction, that means this one, is also not a chiral center. So we can conclude the given molecule don't have any chiral center. So number of chiral center for this particular molecule is 0. Okay, so again we are taking another example for the better understanding. So now I am going to erase this compound and let us draw another organic compound. The compound looks like this. This carbon is attached with a CH3 group. This carbon attached with isopropyl fragment. This carbon attached with OH, and this carbon is attached with another chain of carbon. Okay, now consider this carbon and you have to find out how many chiral carbons are there. It seems to be tough, but in reality this is not a tough example. So let me explain how many chiral centers are there. So let me check one thing. If I am talking about, so this carbon has 1 hydrogen atom, this carbon attached with a CH3, attached with a CH3, here also it has 2 hydrogen, both are same, so no chance of chiral center. It has same 2 hydrogen atom, it has same 2 hydrogen atom, this carbon has 1 hydrogen, this carbon has 1 hydrogen. Is it clear? Now this carbon has another hydrogen, this carbon has another hydrogen. If I am talking about this has also another hydrogen, this carbon has 2 same hydrogen atom, so chance of chirality is not possible here. And if I draw here, the 2 hydrogen atoms are same, and this one is attached with hydrogen and this one is attached with a CH3 fragment. So what about the number of chiral center? You can see I am going to circle the chiral center. Suppose this one, this circle, this carbon is chiral. Why? And if I am talking about this also, it is attached with hydrogen. So the circle carbon is chiral carbon because upper part is different, the right fragment is different, the left fragment is different, and the lower it is attached with 1 hydrogen atom. So this one is chiral. If I am talking about this is also chiral. You can check it. This carbon is attached with this fragment, this carbon in the left side attached with this bigger fragment. top portion attached with hydrogen and the below portion attached with this fragment. So this carbon is also chiral. If I am talking about this carbon, okay, so this is also chiral because the left side and right side different, the top and the lower part different. That means this carbon is attached with 4 different atoms or group of atoms. That means this center is also chiral. If I am talking about this center, I am giving one circle here. This carbon is also chiral because you can see this carbon is attached with 4 different atoms or group of atoms. Okay. And another one about this carbon. This carbon is also attached with 4 different fragments. If I am talking about CH3, H and the left part and the right part, all are different. So now we have 1, 2, 3, 4, 5 and the 6th one is here. You can check it. This carbon is attached with the CH2 fragment. Top part is attached with hydrogen. The left side is attached with this bigger fragment and the right, you can say the lower part is attached with totally different fragment. And the last one is this one, this carbon. So one thing, no, not at all. It is not possible if here out of this CH3 and CH3, if another different functional group or different atom will be there, then only this carbon may be chiral. So now in this picture, since 2 CH3 are same, so this carbon is not chiral. So the circle portions are the chiral. So how many chiral carbons or carbons atoms are there? So now the carbon center which are not chiral, I am going to giving one cross. So this is not a chiral center, this is not a chiral center, it is not a chiral center, it is not a chiral center, this one is not a chiral center, and again this one, the top part, because due to the presence of both the CH3 group, same thing happens here. And if I am talking about this is also not a chiral center. So how many chiral centers are there? You can see total 1, 2, 3, 4, 5 and 6. Now I am writing here number of chiral center is 6. Hope you enjoyed this class a lot. Give your feedback, give your comment. Okay, tata, goodbye, and we will see again in the next lecture video.